3 and 2/3 times 2 and 1 over 11. Number 13. 1 and 1/2 times 4/5 times 2 and 1/6. Okay, let's work on those. Okay, pay attention, okay? Do not write anything yet. Look at the rule, okay? Take the rule out in front of you. Rule number 1. It says change every mixed number to an improper fraction. Problem 1. Do you see any mixed number? No. So skip to number 2.
4.
Cancel wherever possible diagonally. I told you that, right? Diagonally. Diagonal. That's diagonal. That's diagonal. Okay. Can 4 and 6 be reduced? Yes. By 2, right? So if I reduce these by 2, I get 3 for this and 2 for that. Can 3 and 7 be reduced? No. Can 3 and 3 be reduced? But it didn't say diagonally. I mean, it didn't say across. You can't reduce across. You can't. So, are we done with number 2?
No.
Rule number 2? Cancel wherever possible? Okay, now we need to do number 3. Multiply numerators by numerators, denominators by denominators. Okay, 3 times 3 makes 9. Over 2 times 7 is 14. And then look at number 4. Reduce answers if possible. Can you reduce the answer here? Yes? No. Nothing goes into 9 and 14. So that will be your answer. Okay. Now look at number 4. Rule number 1 says change every mixed number to an improper fraction. I see one mixed number here, but that's not. So I'm going to change this to improper fraction. 2 times 1 is 2, plus 1 is 3. So 3 over 2 times, that one stays the same, 2 over 3. Can I reduce them?
Yep.
Diagonally? Yes, I can. 2, I get 1. 2, I get 1. 3, I get 1. 3, I get 1. So 1 times 1 is 1.
And 1.
1 times 1 is 1. That's considered improper fraction. So I need to finish off. 1 divided by 1 is 1 whole. That's my answer. Number 7. 1/2 times 16. Whenever you see a whole number, this understood to be a 1. Always understood if it's a whole number. Okay. Now, it doesn't seem like we have a mixed number here. So what we need to do now is just cross cancellation. What goes into 2 and 16?
8.
No, 2. Right?
2.
2. So 2 can get into 2, 1. 2 goes into 16 8 times. So no more. Multiply across. 8 times 1 is 8. And 1 times 1 is 1. 8 over 1 is improper fraction. Divide 8 by 1, you get 8. So 8 is your answer. Look at 3 and 2/3 times 2 and 1/11. Both of them are mixed numbers. You got to change them to improper fractions. 3 times 3 makes what? 9 plus 2 is 11 over 3 times 2 times 11 makes 22 plus 1 is 23 over 11. The bottom number stays the same, you see? Now, can you cancel 11, 11? Yeah, it goes itself once, right? Okay, 23 and 3, you can't. So just multiply across. You have 1 times 23 is 23. 3
And
times
three.
1 is 3. That's improper fraction, so divide. What's 3 goes into 23? 7 times? Okay, put 7 here. What's the remainder? 2. Over 3. And since you can't reduce to third, that's the answer. Okay. The next one is rather challenging. Okay. Let's focus closely to the next one. You see that you have two numbers that are mixed numbers, but one is not. So let's change everything. Okay. 2 times 1 is 2, plus 1 is 3, so that will give you 3 over 2, and the 4/5 remains the same. And change that. 6 times 2 is 12, plus
13.
13 over 6. Okay, now we can do cross cancellation. When we do cross cancellation, we can always skip as long as it can go into it. And as long as you don't go across, you have to do diagonal. Okay? Look at the 2 and a 4. I can reduce that. I can reduce a 4 and a 6 or 3 and 6. Those two are still diagonal. Okay, so let me see. 2 and 4. I get 1 for 2 and 2 for 4 because 2 can go into both numbers equally. It's easier for me to think about 3 and 6. So what goes into 3 and 6? 3. 3 goes into 3 one time. 3 goes into 6
2
2 times.
times.
Okay. There's one more step. You see the 2 and the 2, both of them are
1 and 1.
diagonal, so I get 1 each, right? Okay. I'm gonna change color here. Back to 1, back to 1. Left out are 5 and 13. I can't reduce those two. I'm gonna be multiply across. 1 times 1 is what? 1 times 13 is 13 over. 1 times 5 is 5. 5 times 1 is still 5. That's improper fraction. Make it proper by dividing. What's 5 into 13?
5.
2
8.
times.
2 times.
I get 10, right? So 10 subtract from 13 is 3 and 5 on the bottom. Can you reduce 3/5? No. Final answer. That's it. Yeah.